Today we're going to take a look at something called a periodic function. And our definition of a periodic function is as input values increase if the output value demonstrated a repeated pattern over successive equal length interval cycles, we have what is called a periodic relationship. So think of things like if you were to imagine this is the height of like a Ferris wheel. A Ferris wheel, it goes up and down, and then it goes back up and down. Maybe you get on it at a height of 3 feet and it goes up and down. Other things that go up and down, you could think about like temperatures. Temperatures through the year, they go through different cycles. It gets warmer during the summer, cools off, gets cold, warms up, cools off. You could also think of tides, like a tide in the ocean going in and out. You could think about the moon, the phases of the moon. You know, where we go from no moon to full moon to no moon to full moon. All of these are periodic relationships. So in a graph, a single period is one cycle. So for example, this is a full cycle right here. It goes high to low. So if we were to continue this, these are kind of some key points here. It starts kind of in the middle, and then it goes high to the middle to the low to the mid. So if I was to keep this going, it's in the mid, it's going to go high again, and then it'll come back to the mid. And then going backwards, this would have to be to the low, and again, 2 over, it would go to the mid, and then to the high. The period is the smallest change in x values that it repeats itself. So like the length of one cycle. So this would be a length of a period. So that's 4, 5, 6, 7. So our period is 8. So this one, it asks us to draw it again. So again, think about cut, copy, and paste it. So it starts at 2, then goes down to 1, back to 2, and then this way. So this is the end, so it would go. And what is the length of a period here? Our period length would be 4. So a definition, the period of a function is the smallest positive value of k such that f of x plus k, it equals the same thing. So how far do you have to go from a value to get back to that exact same point for all of the x values? So when I look at this one, let's say I started here. How long does it take to get to back here? This would be the length of a period. Cut, copy, and paste. So half. You don't have to start there. You could say here. Let me try that in blue. Like, let's say I started here. Now, is this just the full length of a period? I'd say no, because it has to do high and low. So again, you can pick any x values. So what if I pick here? Well, is this the length of a period right there? I'm back to that x. But no, because we're saying the period is length 8, but that wouldn't work for this x value up here. After 8, I don't get back to the same spot. So again, you have to think if you cut, copy, and paste that whole thing. So from -8 to +8, our period is length 16. Okay, so then this last part, periodic, when are they increasing and decreasing? So here's one period. Our period is length 4. So is it increasing or decreasing from 18 to 20? Well, lots of ways you could figure this out. I look at it and say if this is at 4, this would also be at 8, 12, multiples of 4, 16, and 20. So if that's 20, this would be 19 and 18. So from 18 to 20, it is increasing. I could do the same thing from 31 to 32. If this is 20, this is also 24, 28, 32. So that means 31 is right here, 32, and then it goes back. So that would be concave down. And is it a relative min or max at 82? Well, I don't want to keep counting by 4, so I'm going to say, what is 82 divided by 4? Well, that's 20, right? With a remainder of 2. So that means it goes through 20 full cycles and then 1, 2 more. 1, 2, so that would be a minimum.